All right, pencil, paper, calculator ready. Don't worry, you did not miss anything. That's right, we did skip to a lesson 11.6, and the reason we skipped to it is because we need to know what volume is before I ship you on to 7th grade. You're gonna need to know this, and in particular, this is volume of rectangular prisms. So there are other shapes, just like in the last lesson. We only really dealt with rectangular prisms and cubes. There are some other shapes, but we get to what we can. So, what is volume? So, in math, volume is the number of cubic units needed to occupy a given space. So, if surface area is the space touching the outside edges of, like, say, a cardboard box, it's all of the little areas of the outside edges. The volume would be kind of like the area of inside of the box, including like all the air that's inside of the box, or whatever is occupying that cavity in the middle of that space in the middle of the box. So not only is it representative of the inside, but it's representative of the inside like space. So even the part that when you reach into the box and you feel nothing, that is still part of the volume. So volume has a very simple formula. How are you going to find that volume? All you got to do is V equals L times W times H. And I think by now you know that V stands for volume. That's why it is a capital V. L, W, and H is length, width, and height, and those should be lowercase letters. I would prefer the L to be a cursive L, to be honest with you, but they didn't do that here in the book, and I can't do cursive on the computer. But to shorten it up, you could actually write it as V equals LWH, because you remember in algebra, the default operation is multiplication. So it could be V equals LWH instead of L times W times H. So we have a bento meal. It's a single portion meal that is common in Japan. The meal is usually served in a box. A small bento box is a rectangular prism that is 5 inches long, 4 inches wide, and 2.5 inches high. How much food can the box hold? All right, so for purposes of this problem, they're considering this line right here, your length, this line right here, this 4-inch line, your width. This would be 4 inches as well. This is 4 inches. This is 4 inches. And then the height would be the one that goes up and down. And that's 2.5. But you know by now it doesn't really matter because you can hold the box differently, and your interpretation of what the length, the width, and the height are might be different. So on your paper, this is what you got to write down. You could draw the picture if you want. If you think you're good enough to draw this picture, go ahead and draw it. Some people cannot draw 3D objects. That's okay. But what you got to write down on your paper is that this is lesson 11.6, and this is the unlock the problem, and we're going to write down the formula first and foremost. Capital V equals lowercase l, lowercase w, lowercase h. You could put the floating dots in there if you want. I wouldn't put the x's in there for multiplication. You know that by now. Now let's go ahead and let's substitute our values. If I said it once, I've said it a million times. It doesn't really matter which one you consider the length, the width, or the height. You also know from chapter 8, I believe, that the commutative property says you can multiply numbers in any order and still get the same answer. I will play along and consider this the length, this the width, and this the height, but it doesn't matter. So substitute those values, and from here, it's just one more step. Just go ahead and multiply them. You could actually type them all in to any type of calculator you're using, and you should get the same answer. So let's make sure this progression here is on our paper first before I explain the other stuff. So it's going to be V equals, or volume equals, 50 inches. And then instead of a 2 for an exponent, we're going to put a 3. And we mentioned this briefly in class. But that 3, instead of saying to the power of 3, we can say cubed. We talked about that when we first learned exponents in chapter 5. So what we are always going to have for volume is it always has to be cubic units. whatever it is, whatever that unit is. In this case, it's inches. Could be feet, could be meters, could be millimeters, could be yards. It always has to be cubic units. So there's two basic ways to write it. You could write out 50 and then write out the word cubic and then write whatever that unit is. Or you could do CU, I guess would be the abbreviation. Or the more popular way, you just put inches and then put a little exponent 3 there. So on your paper, you shouldn't have any trouble putting that exponent 3. But when it comes to typing it into your Google form, if you just put in the number 50, that would be good enough. If you know how to do the exponent 3, go ahead and go for it. But it varies depending what device you're using. And I don't want you to get too bent out of shape just typing in the number. So make sure this is what you see on your paper. Inches cubed, that's how you say it. You don't say to the power of 3 or any of that. It's 50 inches cubed. That is your volume.